Okay, today we're going to be going over functions and what functions are, what functions mean. Functions can get very confusing if you dive too into it, but we're not going to dive all the way in. We're just going to hover over the surface, know what the GED is going to throw at you in terms of functions, and you're going to do the worksheet and then move on. Very quickly, let's say we drew a couple graphs, right? And we drew something on the graph, such as this, such as this, such as that, such as this, right? If I were to tell me what each of the things, each of the lines are on the graphs, you would have to say, oh, this looks like a circle, this looks like an S, this looks like a W, this looks like zigzag patterns. But instead of saying all that, we could just say each of those are functions, right? Or I should say trying to be a function. That's what kind of saves a little bit of time. The functions, all it is the thing that's on the graph, right? So we've been dealing with lines a lot, right? And that's as far as we go in terms of graphs. But you got to understand those lines are technically functions. It's just the thing on the graph. But here's the thing. There is a rule that you got to follow. Now, I said these things, you call them functions, but some of them aren't, okay? There is a rule on what really is considered a function and what isn't. That rule comes from one specific thing, and that is if at any point you have 2 points on top of each other. This is what I mean by that. You cannot have a function is not technically a function if it has 2 points above each other. So if you recall in the last lesson, I gave you a graph and then I drew a flat line, and I said the way the linear equation of this will look like is y equals whatever it crosses down here. Let's pretend this crosses -4. That's the linear equation. But if you recall, I did say if you are given a graph and then you have a vertical line, it's considered undefined. There's a reason because of that. It's because if you were to at any point pick 2 spots, 2 points are on top of each other vertically. That is disallowed. That is not allowed in the function world. This guy right here is trying to be a function. He's faking a function, but he ain't a function. If you were to say, is this a function? The answer is no, it is not. So, on the GED, you will be given a question. They will give you, well, let's just look at this perfect example. Let's say if they give you 4 graphs to choose from. Option A, option B, option C, and option D. All right. And the question that you're going to see on the GED, write this in your pile of GED questions that you were going to come across that I've been giving you along the way. But you will be given a question that says, identify which of the following graphs represents a function. That's an exact question from the GED. How do you determine which graph is a function? Well, you look for that rule that I told you. Check your line or your circle, your S, your W, your zigzag, whatever it is. Check your pattern that's on the graph. Check your function and determine whether at any point do you have 2 points above each other. The best way to do that is doing something called the vertical line test. The way we do that is on your function, draw a vertical line. That wasn't so vertical, but you get the idea. And then on that vertical line that you just drew, pinpoint where exactly your vertical line touched at any point your function. And in this case, I touched it there and I touched it there. Did you touch it more than once? Yes, in this case, I see 2 points. That means this is not the function. Because remember, a function is only a function when it has 2 points above, when it only has 1 point and no 2 points above each other, no more than 1 point above each other. So let's do the same thing here. Boom. At any point, you can just do a vertical line anywhere. And at this point right here, I see there's 3. This is not a function, right? Let's do one here. Vertical line. Oh, I only touched this function once. This one passed the test, but always double check in multiple spots. Do multiple vertical lines. Another 1 point. another 1 point, another 1 point. Check multiple spots, because sometimes they will trick you with giving you something weird like this. They might give you a graph like this. Boom. If you were to technically do a vertical line here, yes, you only touched it once. But if you touched over here, you touched it more than once, right? So that's how they sometimes like to trick you. But just check multiple times doing your vertical line test. And I could just stop right there because I know this will be the answer. And if you just want to triple double check, just do a vertical line here. And what do you know? That was an ugly vertical line. Boom. 1, 2, 3, 4, 5. That one went all over the place, right? So that is how you identify function. This is the purpose of today's lesson, is to better your eye with determining what's a function and not, right? So this is how you determine whether a graph is a function, whether they give you a visual picture and they ask which of the following is a function. They could ask it to you in multiple different styles. For instance, they could technically give you this type of graph right here, right? It's not a coordinate plane, it's just a one quadrant of the coordinate plane. And let's say they give us points instead. Boom, 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 boom. And then they want you to hover over with your mouse. You'll literally have a mouse on the GED, obviously, right? And they want you to click. Let's say the question is like this. Click on the following point needed to be removed to make this a function. Because technically right now, if you did not know, it's not a function. So then you have to click on the point you want to delete so that it makes it a function. So now comes the question, which point do you delete? Could you determine which one it is? Huh? Done, done, done. The point that you're going to delete is either of these ones. If you notice, these are the ones with 2 points above each other. So either of these ones would have been correct. You could have deleted that one. Boom, it's a function now, right? Or you could have deleted this one. Boom, it's a function now. So that's just a spin-off, different type of way they might ask you a question. But still in the same format of functions. All right, so that's functions graph-wise. Just like before, there's a mathematical way too. They might give you, instead of a graph and tell you determine which of the following graphs is a function, they might actually give you a table instead. Now, this is a good part to introduce you to tables. This is a good introduction to tables. Tables are no different than graphs. I don't think you've noticed this, but you could graph this easily. How? Well, if you didn't know this already, it says X and Y. My friends, all the numbers that you see on the table, all it technically is are points. You could easily graph this. Easily graph this. I don't know why this undo is not going away. If you know the x-axis is 3, 1, 2, 3, 1, 2, 3, 4, 5. This first point, well, you'll go here. On the y, it's 5. It's up there. And then you go off and pinpoint all the other points for all the other coordinates that they gave us in this table. But tables are no different than graphs. But here's the thing. Just because I'm telling you that, I do not want you to think that you are going to go graph this line or function and then do your vertical line test on it, because that'll be too long and you don't have graph paper on the real GED test. So trying to graph this out and pinpoint where all the points are at, right, is going to take too long, and then you have to be very precise, right? Unless you have grid paper, I wouldn't recommend that ever. There's a mathematical way, there's an easier way when given a table to determine whether a table is a function or not. Because what they can do, and what they might do, what they will do is, like before, one question they might give you is 4 graphs. What they could also give you is 4 tables and say, which of the following line is a function? Because remember, these are lines, or it might not be a physical line, it might be a zigzag or whatever. So they might just give you 4 tables and say which of the following represents a function, right? So how do we determine whether a table is a function? By this little rule. The little rule is this right here. Ignore the y for a brief second. Pretend you don't see any of the numbers. And then ask yourself, you're just always looking at the x-axis. Ask yourself, do you see any repeated numbers? Now, here's the thing. I do see two repeated numbers. I see a 3 and a 3, okay? Let's say we didn't see a repeated number. Let's say it was a whole bunch of other numbers, but none of them repeated. That will forever be a function. You could immediately just say, yup, this one's the function. If you don't see no repeated numbers on x, that's always going to be a function. Here's the thing though. Most likely they're not going to make it that easy. They're going to put a repeated number. Now, if you see a repeated number, don't immediately say, oh, it's not a function. No, because this could still technically be a function, but it could not. And it all determines one thing only. Those repeated numbers, what you're hoping for is that when you uncover your y section, you're hoping that those two matching numbers have the same matching y's. Not matching in terms of the y's have to be 3, right? What I mean is it could be any number, but both of them need to be the same in order for this to be a function. So if we go to unclear our y section, boom, what we notice is this 3 has an output of 5, and this 3 has an output of -7. Two different numbers. This, my friends, is not a function. Okay? Do you see that? That is the rule. You're just always looking at the x-axis, and you're either determining, if you need to determine whether it's a function or not, you're just seeing if you see any repeated numbers on the x-axis. If there's no repeated numbers, easy peasy, it's a function. If you do see repeated numbers, you're just hoping and wishing that those numbers have the same output. I say output, that's just the same number on the y side. So, wrote out this example here. We have option A, we have option B, we have option C, and option D. Can you tell me which of the following tables represents the function? So, what was the trick that we went over? Always look at the x-axis. Forget about the y for a brief second. Just look at the x-axis and determine whether you see any repeated numbers or not. In this x-axis, I see a 7 there and a 7 there. Okay, that's totally fine. It could still technically be a function. You're just hoping that the outputs, aka the number on the y side, are both the same. So here I see a 2 and a -2. Are they the same numbers? I try to trick you. 2 and -2 are two different numbers. A positive number and a negative number are completely different. You guys should know that. So this is not the function. Here, do I even need to look? All I see is the same numbers on the x-axis, and all of them seem to be different. So I already know this one, it ain't it. Here, 5, 6, 7, 8. I see no repeated numbers, my friend. I see no repeated numbers. You're done. But I see repeated numbers are 9. No. On the y side, it doesn't matter what numbers there are. If you happen to see no repeated numbers on the x side, that's always going to be the function. You got it, right? Now, again, let's say there was the same number. So let's say there was a 5 here. 5. This will still be a function because, again, those two matching 5s have same matching numbers on the y. So just that's it. And over here, look I see a -7, -7. Both of them have different outputs. I didn't even have to check that. I already knew this was the answer. So that's how you determine table functions. One way they might trick you on the GED is a fill in the blank. So it's not really a fill in the blank. It's more like a drag and drop. Let's say they give you this and they say, the question is, drag and drop whatever following number is needed into the empty slots to maintain this as a function. Right now it is a function. So what numbers must go in there so that it continues being a function? And then they say, do not repeat any of the ordered pairs. That just means if you see a 2, 6 here, they don't want you to make it easy on yourself and put a 2 and a 6 there, because that would mean 2 of the matching ordered pairs. Yes, you're right. That would still make it a function, but the directions specifically said they don't want that. That's because the GED just doesn't want to see it. You got to obey the GED question, right? So we have a function currently. They want us to drag over a couple numbers that still keeps it as a function, but it can't be the same ordered pairs already used in the table. So what options can we drag over? Take a brief second, push pause, look at it. It's totally fine. The options, my friend, there's only two options. On the x-axis must be either the 1, this one you're going to drag it over there, or the 6. Those are the only two options that could go into x. All right. If you were to put the 2 here, you're wrong, because by default, in order to keep this as a function, you'd have to put a 6 there. But the direction specifically said you can't repeat any of the same numbers. So those ones are technically out for the x-axis because they're all there. 2, 4, 5, 3. 2, 4, 5, 3, right? We cannot use those numbers. We just can't. So it's either 1 or 6. It doesn't matter. Just drag over whichever one you want. And then here for the y side, like I said before, it doesn't matter what number you drag over. You could literally bring over a 2, the 6, the 5. It doesn't matter because whatever number you do put in here, including the 1, it's not going to be the same as any of the other ordered pairs. So it'll keep it as a function, and you don't break the rules of repeating any ordered pairs from before. You're solid here. So hopefully this was all the tricks you needed to know on the functions, how to identify functions. On the worksheet, all you're going to do is for each table that's given, each graph that's given, you just got to determine whether it is a function. Be aware, tables sometimes can look like this. All they do is get this and make it vertically, but it's not a big deal. You just got to identify what your x is. If they give you this right here, it's just a matter of either rewriting it so it looks vertically if you're used to that, or just, again, hide the y-axis always. Hide it from you. Check whether the x-axis has any repeated numbers. Just follow the same rules. Horizontal tables are no different from vertical tables. So just answer the questions. Yes, it's a function. No, it's a function. And then you'll be done.